Okay, good morning, good afternoon, and good evening to every one of us. Welcome back, even as we run through again our worksheet 6, which deals with logs and exponential functions. So today I want us to focus on equations. So these equations are basically in both aspects of exponential and logarithmic way forms. So we are looking at both logarithmic functions and exponential functions. So let's find or maybe solve a number of equations which we have on our worksheet 6. I'm sure every one of us has our worksheet 6. Copperbelt University BS-140 worksheet 6 2025. So we'll focus on question number 10. Once we exhaust question number 10, we'll look at question number 11. Okay, let's run through of what we have. So let's look at the first one. So number one, if you want to solve exponential and logarithmic equations, the first thing you're supposed to understand is basically knowing the rules of exponentials and rules of logarithms. So I'm sure my questions are reflecting there on the board. So I'll start from the first and I'll run through a number of them. So we have the first one there, which is question number 10, where we are solving this number of equations. A says that let's solve this equation, which is the natural log of e power negative 3x minus 1, and then here we have 3x equal to 0. So number one, know all the rules, because the rules basically, I'm always emphasizing, if you know the rules, everything will move smoothly. If you do not know the rules, it will be very much difficult for you to solve a number of things. So A there, let's solve that equation. So once you see a log function or a log equation, think of strategies and ways on how basically that can be simplified in a way you're able to solve for x. So the first concept is that once you see this is just a normal thing in a linear aspect, but this guy, in short, look at where your x is. Here the x is just basically normal as in a linear aspect, but here the x is in a power. So it will be very much difficult to solve this equation because another x is in the non-can, another x is in the power. So try by all means to simplify it so that it can be in a version you will solve without any difficulties. Number one, someone would simply say that this is just basically the natural log of e power negative 3x minus 1, and it takes this to the other side, becomes equal to positive 3x. This is very much correct. So the easiest to solve this equation, we are going to convert it to exponential form. Convert to exponential form. So if I convert that to exponential form, what am I going to have? Remember, the conversion to exponential form, if we have the log of a certain base x equal to y, this can be converted in exponential form by getting the base, raising it to the output, which is y, to be equal to the input, which is x. So what am I having here? The natural log is the same as the log of base e. So natural log of x is the same as the log of base e x. So if I see a natural log here, I know that there is a base of e somewhere there. So converting it to exponential form, the base is e. So this form, so if I have the natural log of e power negative 3x minus 1 equals to 3x, this can be written as the base of e, which is the base, power the output, which is 3x, to be equal to the input, and the input is e power negative 3x minus 1. So at least now the variable x is now all the values of x, the variable x's are in a power. it means with that being done, at least things will become number to be what? To be very much easy for us. So we are now working with this equation. So this function is the same as this. So we'll solve for x using this because this one is the simplest. It's simpler to use compared to the first one. So conversion, from conversion we have the exponential form. We'll use the exponential form to solve. So let me delete just this part. So we're now going to use e power 3x to be equals to e power negative 3x minus 1. So from there, now let's use that to solve the value for x. So what am I going to have here? We have to understand that if I have this e power negative 3x, this e power negative 3x is the same as e power 3x to be equals to the negative can be written as 1 over e power 3x minus 1. So doing so, to get rid of the denominator, what can I do? Multiply through by e power 3x to get rid of this denominator, implying that every term will be multiplied by this guy. So e power 3x times this, it will be basically e power 3x times another e power 3x, just basically I'm getting this squared. Okay, this is being multiplied twice. This times this, it is this same squared, equal to this times this, it is it's more like we have 1 over e power 3x multiplied by e power 3x over 1. So this and this will go. So what am I going to remain with? I'll just remain with this times this, I'll remain with a 1. And this times this, you remain with minus e power 3x. And taking everything on one side, this can be as good as e power 3x. When this one crosses, it becomes plus e power, this is squared, sorry. This goes to the other side, becomes plus 3x. When this goes to the side, it becomes minus 1 equal to 0. And if you have bigger eyes, you're able to see that basically what is being formed here is a quadratic equation. So if I let what I'm seeing here and what I'm seeing here, if I let e power 3x be any letter of my choice, let's say y. So what am I going to have? I'm now going to have y squared, this is e power 3x is y, plus this 3 power x is y, minus 1 should be equal to what? 0. So this time around we are solving for y now. So once we solve for y, we'll come and put it back to solve for x. So let's solve quadratically. Two numbers, when you multiply, they'll give us a negative 1. And when we add them, they'll give us a positive 1. Do we have any of those two numbers? Multiply them, they'll give us a negative 1. And when you add them, they'll give us a positive 1. I'm sure it is impossible to find those two values. So don't be afraid to use the formula method. So the formula method says that since I'm looking for y, y will be equal to negative b, positive or negative, the square root of b squared minus 4ac over 2a. So this means that my y is equal to b is 1. So this will be negative 1, positive or negative, the square root of 1 squared minus 4. Am I correct? Minus 4. And then a is what? 1. And c is what? Negative 1. Over 2, because a is 1. So basically my y will be equal to negative, positive or negative, the square root of negative 4 times negative 1, that's a 5. So I'm going to have, am I correct? Negative 4 times negative 1, that's what? Not 5, but positive 4. So I'm going to have 1 plus a 4 in here over a 2, so that we can have y to be equals to negative 1 positive or negative the square root of 5 over 2. So remember, you guys, you have calculators. So once you find the value of y, in this case, my value of y will be equals to the first one, negative 1 plus root of 5 over 2. Another one will be y will be negative 1 minus root of 5 over 2. So what are we going to have? The square root of 5, the square root of 5 will basically give us what? Square root of 5 will basically give us 2.24 to correct two decimal places. So this is basically y equals to 1 plus 2.24 over 2, or y is equals to negative 1 minus 2.24 over 2. So this plus that divided by 2, so this will give us, this is a minus 1, the answer divided by 2. So this is approximately 0.62 as the first answer. And this side we have y to be equal to, we are going to have 2.24 plus 1 divided by 2. This is negative 1.62. So these are the two values of y. But remember, we are looking for x. Y just assisted us in finding, is just trying to assist us in finding the value of x. So now let's find the value of x. Let's find the value of x. So the value of x here will be found by recording that e power 3x was equal to y. E power 3x was equal to y. Let me just delete this first part. So if we recall that e power 3x was equal to y, we have two values of y. The first one can be e power 3x is equal to 0.62, and the other one should be e power 3x should be equal to what? Negative 1.62. And I'm sure once you have something like this, you should be able to now analyze your values. What is going to happen here is that somehow this will be an invalid solution, to be undefined, because an exponential form in this form can never be a negative value. So this will somehow be undefined, and this will give us the correct solution. So if we want to solve the value for x in this case now, we can now, since we are talking about e, applying the natural log on both sides, natural log of 3 power x, the natural log of 0.62. This from the power it drops down becomes 3x, the natural log of e, to be equal to the natural log of 0.62. This natural log of e is 1, so I'm going to have 3x divided by 3 divided by 3, so that the value of x becomes the natural log of 0.62 divided by 3. So I'm going to punch natural log of 0.62 divided by 3, and I'm going to have negative 0.16. Negative 0.16 is the value of x. But if you were using this one, let's say we were punching the natural log on both sides, we're going to have something like 3x natural log of e to be equal to the natural log of negative 1.62. So if this is a negative, if you punch this in your calculator, this will be something like a math error. This is undefined, because inside here should never be a 0 or a negative. That is why this part for us it is invalid. The only part which is going to give us our solution, it is this part where y is positive. Negative 0.16 will be our solution. So in most cases, if you have something like this, the easiest would be convert it to exponential form. In most cases, the easiest is converting it to exponential form. Once you convert it to exponential form, at least you'll be able to find your desired values. The same is happening with B. You can delete this part. This was our A. Let's go to B now. The same is happening to B. So B has that the natural log of e power negative 3x plus 5 is equal to 0. The natural log of e power negative 3x plus 5 is equal to 0. Find the value of x. So, as usual, first thing is to convert to what? Exponential form, because this is something which is similar to the previous one. The base here is e. So, converting this to exponential form, this becomes e power 0 should be equal to e power negative 3x plus 5. The base power output should be equal to the input, like that. Then, from there, we continue. E power 0 is always what? A 1 to be equal to e power negative 3x plus 5. This is very much simple. Now, like terms together, when this one crosses the other side, becomes 1 minus 5 to be equals to e power negative 3x. And this guy becomes negative 4 to be equals to e power negative 3x. We want this guy to come down, natural log on both sides. I'm going to have the natural log of 4 to be equal to the natural log of e power negative 3x, implying that the negative 3x drops down. Natural log of e is 1. And this side I have the natural log of negative 4 over negative 3 over negative 3. This goes, and the value of x becomes the natural log of negative 4 over negative 3 as the value of x. But look at this solution now. What is the natural log of negative 4? The natural log of negative 4 becomes undefined. This is undefined. So if the natural log of negative 4 is undefined, automatically the value of x is what? It's an undefined solution. So therefore the complete solution of x will be equal to what? Undefined. So if x is undefined, what can you conclude to this equation? This equation is a no solution equation. There is no value of x which is going to be defined in this equation. We are okay? Yeah. So the same is happening with C. What are we using here? We're just basically using properties, rules, everything. And the easiest in most of the times for logs, we're trying to convert it to exponential form in most cases. So if I'm seeing the x being in the input, at least somehow the easiest way is converting to an exponential form. Okay, let's look at C. Let's look at C. So for C, we have that 1 over 2, the natural log of x is equal to 1 minus the natural log of 2. That's what C is. So now, we have two logs there. First thing, if you have two logs there, simplify it to be of one log. That's the first concept. So once we simplify it to be on one log, we'll be able to solve other things. Simplify it to be of one log. So let's simplify it to be of one log. What am I going to have? Maybe I can take this to the other side. I'm going to have 1 over 2, the natural log of x. When this other log crosses, becomes positive. Natural log of 2 is equal to 1. So for this guy, can climb up, and I'm going to have the natural log of x power 1 over 2 plus the natural log of 2 is equal to 1. The plus here and of the same base, that is indicating a multiplication principle, meaning that I can have the natural log of, in the input, I have x power 1 over 2 multiplied by what? Multiplied by 2. Should be equal to what? Should be equal to 1. So, we want to find the value of x. Let's convert to exponential form. The base here is now e. So I'm going to have e power 1 is equals to x power 1 over, this time this is just basically 2x power 1 over 2. We are okay? And we know what e is. Anything power 1 is that same e. So this is just basically e. So I have e is equal to 2 power x power 1, or that. So for me to find this value of x, divide by 2, divide by 2, this goes, means that x power 1 over 2 is equal to e over 2. How do I get rid of this power? Multiply both sides by, square both sides, this and this goes, implying that the value of x now becomes e squared over 2 squared, which is a 4, as your value of x. If you want, you can simplify it further by punching in what is e squared divided by 4. It's still the same thing. So what is e squared? Punch in e squared on your calculator. So I'm going to have e 2, that's that, multiplied, divided by 4. I'm going to have x to be equal to 1.847 as the value of x. Very simple, like that. We are okay? The same is happening with g. The same is happening with g. Maybe g is very simple. I will leave that g to be your task. Let me talk about maybe j. Someone will simply say j is a little bit complicated. Let me talk about j. How do I look at j? So what am I going to have? On j I have the natural log. J, where are you? On j I have the natural log of 1 minus x power 2x, like that, minus natural log of e, I'm writing off it, e power x plus 1 is equal to 0. So we have the natural log of 1 minus x power 2x minus natural log of x, e squared, e power x plus 1. What are we simply saying? The first step, it is to convert to what? To express as one log. Expressing this as one log becomes what? I'm going to have the natural log of, this is subtraction here, so I'm going to have division, 1 minus x power 2x divided by ex plus 1 is equal to what? 0. Convert to exponential form, the base is e power 0 is equals to 1 minus x power 2x over ex plus 1. We are okay? And after doing so, what do we have? So we have that e power 0 is just basically the same as what? The same as 1. So this is going to be 1 equals to 1 minus x power 2x over ex plus 1. We are okay? So now, this question is something which is very much complex if you look at it very well. So we have the x being the base. Again, the x is also found in a power. We are okay? We have the x being the base, and the x again is being found as well in the power. So that's one thing we're supposed to be able to understand there. So what is happening there is that can the difference of two squares work out here? This is just the same as 1 minus 2 power x, which is the same as 1 plus x power x, and 1 minus x power x. If you look at it very well, that's the same as that. But since we don't have that yet, we can leave it the way it is. Okay. So now, this is the variable x, and this is another variable x. So, for the fact that I have the base and again the x is found in a power, it will be very much difficult to solve this guy with the knowledge we know right now. So, basically for now, I will leave this question on another stage later on, because with the rules and properties we know current right now, breaking down or decomposing the x and the power, we are trying to solve for x, and the x is found in the power, and the x as well is found in what? In the as the base. So somehow I'm trying to analyze this to be in a situation where this, if you look at this question very well at your level, I'm trying to understand it like this somehow was a typo error in your worksheet. This was not supposed to be x, but instead it was supposed to be e power 2x. So for now, I want us to change the question. Instead of it being x, we'll change this x to e. We'll change this x to e. I want us to do that. Basically, because if it is x, it will be very impossible for us to solve it. So it means that this x is our e, and this x is our e. So what am I going to have? For the fact that I have something in this format, we have to understand that, we have to recall that 1 minus e power 2x is a difference of two squares. So if it is a difference of two squares, what happens? 1 minus e power 2x is the same as 1 minus e power x and 1 plus e power x. So if I replace this guy on top here, this becomes 1 is equals to 1 minus e power x and 1 plus e power x. And in the denominator here we have ex plus 1. Now look at the summation. The summation, if I say e power x plus 1 and 1 plus e power x, is indeed the same thing. So it means that this guy and this guy will go. So if those guys go, I'm going to remain for 1 is equals to 1 minus e power what? Power x. Implying that like terms together, this will be equal to, this crosses the other side becomes e power x to be equals to 1. When this one crosses the other side becomes minus 1. So it means that e power x becomes equal to what? 0. And if it is e power x equal to 0, what are we going to have? This solution is going to be undefined again. We don't have a solution. Because if we punch in the natural log on both sides, I'm going to have x to be equal to the natural log of 0. And this natural log of 0 is basically what? Undefined solution. So, what we have just done in this question, we have just changed where there was x here, we've put an e. Because if it was an x, it becomes very complex. I'm sure it is not even something which our level can handle for now. So we just converted the question to have an e to be in that format. We are okay? So the same is happening on m. There. The same is happening on n. There. So m and n. So how many questions am I going to leave you with these log equations? Just from the concept which I've just talked about right now, I want you to look at, I would love you to look at, you have to look at, I said C is yours, have I solved C? I did C. So I said G and J, we've looked at it. M, look at M. and look at n. Based from this concept which I've just talked of log equations. So G, M, and N. Submit to our inbox. Submit to our inbox. Okay, now let's just top up on number things to do with exponential parts. Things to do with exponential parts. Let's look at D. Let's look at D. So if I have D there, to have e power x plus 2 over e power x minus e power negative x to be equal to 1. How is that going to be? So this is now going to be implying that now with such things, sometimes be able just to have big eyes and see, use all the knowledge you know in mathematics. So for me to solve this one, I will be able to say, okay, what can I do to simplify things there? Properties of exponential functions. So if I look at the properties of exponential functions, I know that this top part is the same as e power x multiplied by e squared. That is why it ended up to have x plus 2. In the denominator here, I can factorize my e power x there by simply saying if I divide by factor out e power x, I'm going to remain with the 1 there. If I factor out the e power x there, what am I going to remain with? I'm going to remain with e, because divided by e power x, it will be e power negative x over e power positive x. So this will just be eventually have what? E power x negative x minus x, having us to have e power negative 2x. So this will be e power negative 2x. Something like this. When we factor out, remember when you're factoring, so if I'm factoring e power x, it will be e power x which is being factored out. Each term will be divided by the factor. E power x divided by e power x is 1. E power negative x divided by e power x is e power negative 2x from the exponential properties. We are okay? So that if this is the case, I'm going to have this to be equal to 1. So since these are dividing, this e and this e can go, and this is since equal to 1. So if I do the cross multiplication there, what am I going to have? I'm going to have e squared, this times 1 equals to this. This times 1 is equal to 1 minus e power negative 2x. We are okay? So that if that is done, now let's simplify things. The variable which I have here is this guy. These are numbers. Don't get confused with this e. This is a number. This is e, which is just been squared. So we'll make this guy the subject. So if this one crosses, it becomes positive e power negative 2x to be equals to 1. When this one crosses, it becomes minus e squared. So that if I do the natural log on both sides, I'm going to have the natural log of e power negative 2x equals to the natural log of 1 minus e squared. So that this drops down because natural log of e is 1. So I'm going to have negative 2x is equal to the natural log of 1 minus e squared over negative 2 over negative 2. And the value of x becomes the natural log of 1 minus e squared. Number, let's look at what e squared is. So if I look at my calculator there, I punch in e squared, I'm going to have that. If I subtract from 1, it will be a negative 6.3 something. So this would be like the natural log of negative 6.39. This is what I'm going to have over that. But this is a negative inside the log. If inside the log I have a negative solution, means this guy Pamwamba upper is undefined. And if this is undefined, it means that x as well is what? Undefined. So therefore, if you look at all these solutions, this solution is basically what? Undefined solution. Since the natural log of negative 6.39 is what? Undefined. From here, from this concept. E squared, basically E is on your calculator approximately 2.718 morpheme. So if you square this and then subtract from 1, it is negative 6.39. So we don't want to have a negative thing inside the input. We are okay? Yeah. So that is it, our D part. Let's go to E. Let's go to E. E as well is very much simple. E as well is very much simple. But let's look at it. So on E there, we have 10 over 1 plus e power negative x. We are solving for x there as well. We are solving for x as well. So the variable here is on this guy. So this is over 1. We can cross multiply from there. This times this, I'm going to have 2 open bracket 1 plus e power negative x to be equal to, this times this is basically what? A 10. Delete this 2 by dividing multiply by 2. This goes to mean that 1 plus e power negative x is equal to 5. 1 goes to the other side, becomes e power negative x is equal to 5 minus 1. E power negative x is equal to a 4. Natural log this side, natural log this side. Negative x drops down. Natural log of e is 1, is equal to the natural log of 4 over negative 1 over negative 1. And the value of x is equal to the negative of the natural log of 4. And you can find what is the natural log of 4. So the natural log of 4 is just basically 1 point times, so the negative of 1.39 as our final solution. We are okay? The same is happening with f. So f there, properties of exponential functions should be obeyed. So let's look at the f part. So if I have, this is what? F. If I have 2, 3x minus 4 to be equal to 5x plus 2. What is going to happen from there? I'm going to have, so let's break down the powers. This left hand side can be given by 3 power x multiplied by 2 power negative 4. The same thing is equal to 5 power x multiplied by 5 squared. Rules of what? Exponentials. If we have two bases, two expressions of the same base, what do we do to the powers? We add the powers. So it will be 3x plus negative 4. No one, it leads to 3x minus 4. Here to be x plus 2, it came from 5 power x multiplied by 5 squared. Now, we want everything which has the x to be on one side. We want everything which has an x to be on one side. So what can I do so that everything which has an x can be on one side? So I can, for this, for me to take 5x this side, I'm going to have divided by 5 power x divided by 5 power x. Means that this guy will go to the side. For me to take this guy this side, I'll divide by 2 power negative 4, leaving this side 2 power negative 4. So that this guy goes and this guy goes. I'm now going to have 2 power 3x over 5 power x this side to be equal to 5 squared over 2 power negative 4. So if this is the case, what am I going to have now? So we can factor out the square. If I have x here and I have x here, this can be written as 2 power 3 over 5 open brackets power x to be equal to, I can evaluate this. What is 5 squared? 5 squared is 25 divided by 2 power negative 4. And 2 power negative 4 is what? 2 power negative 4. We're going to have that. And if I have 25 divided by this answer, we're going to have a 400, if I'm not mistaken. Am I correct? Yeah. So we have 25 divided by 2 power negative 4. So we have a 400. So I'm going to have a 400 this side. So here we have 8 over 5 power x to be equals to a 400. We can even divide in advance. 8 divided by 5 will give us what? 1.6. So this will be 1.6 power x is equals to a 400. So now let's find the value of x. X is in the power, so we can punch in natural log on both sides, natural log this side. X drops down, so I'm going to have the x natural log of 1.6 is equal to the natural log of 400. Delete this one, natural log of 1.6 over natural log of 1.6. This goes, and x is equal to, what is your natural log of 400? Natural log of 400 becomes that divided by the natural log of 1.6. And I'm going to have 12.75 as the value of x. As simple as that. So running through, first I had to look at the exponential property. 3x minus 4 is the same as 2 power 3x multiplied by 2 power negative 4. 5x squared x plus 2 is the same as 5 power x multiplied by 5 squared. Now want everything which has an x to be on one side. So we divide by 5 power x so that this 5 power x should go to this side. Here I don't want this guy, so I will divide by 2 power negative 4 so that the answer should go this side. So this goes and this goes, I'll remain with 2 power that and 5 squared power that. Until when we reach this stage now, since the power is x, we apply natural log on both sides and we can find the value of x in that manner. We're okay? The same is happening with h. The same is happening with h. And the same will happen at I. The same is going to happen, so h and I. The rest of those, we did them in the introduction of exponential functions equation. So let's look at h. So h there says 5 power x minus 2 over 7 power negative 1 plus 3x. This will be equal to 1. So it's the same thing like the previous one. If you want 2, this is over 1, cross multiply. This will be 5x minus 2 is equals to 7 power negative 1 plus 3x. Then break it down. This is the same as 5 power x multiplied by 5 power negative 2 is equals to 7 power negative 2 multiplied by 7 power 3x. Everything which has an x to come on one side, so it means we'll divide by 7 power 3x here and 7 power 3x there. We don't want this guy, we divide by 5 power negative 2 and 5 power negative 2 there. This goes and this goes. So I'm going to have 5 power x over 7 3x is equals to 7 power negative 1 over 5 power negative 2. We're okay? so that we can have 5 over 7 power 3 outside x is equal to, the negative is common, it's the same as saying 7 over 5 squared power negative 1. We okay? These are just basically rules of exponents. I've just factored out my negative 1. After that, we can take it up and now solve for x. We can now simplify. You can even simplify in advance what is inside. This is basically 5 divided by 7 power 3 and 7 divided by 25. So 5 divided by 7 power 3. I'm going to have 0.015. Confirm my, I don't know, I don't trust my calculator. 0.015. This is power x to be equal to 7 divided by what? 25. So this 7 divided by 25, isn't it? So now the answer raised to power negative 1. This is just the same as 1 divided by the answer. So this will be equal to 1 divided by the answer, and I'm going to have 3.57. Natural log on both sides, natural log of 0.015 power x equals to the natural log of 3.57. X drops down, x, the natural log of 0.15 to be equal to the natural log of 3.57 over natural log of 0.015 over natural log of 0.015. This goes, and the variable x will now be equal to natural log of 3.57, natural log of 3.57 divided by natural log of 0.015. Confirm these answers because I don't trust my calculator. So this will be equal to negative 0.303 as the value for x. Simple as that. So this was question number 10. So you can now do question I, which is just basically the same as what we've done there. And the rest, it means we have done. So just to top up on what we already have, do question number I. And this I says e power 2 minus x should be equal to 2 power x minus 1. Do I. And those two ones remaining, basically we did them in the introduction video. Thank you very much, and see you in the next video as we'll be looking at the simultaneous equations on question number 11.